ray diagram for an object between F and C on a concave mirror. Every time I think about F and C, I can't help but think about The Office, where Michael Scott calls for the Cryman Squad. F and C stands for the Crisis Management Squad, front and center. Anyways, love that show. So here's our object between F and C and a concave mirror. So we're going to draw 3 rays again. And the first ray is going to travel from the point of our object parallel to the principal axis, as parallel as I can make it. And then it's going to hit the mirror, travels, like I said, from the point to the mirror, and then it's going to travel through the focal point, backwards through the focal point. All right. Now, in keeping in line with our past videos, I'm going to draw the dots. But because I've done this before, I know something that you may not. But we're going to draw the lines anyways. So that's our first ray. The second ray we're going to draw is going to travel from the top of the object through the focal point and then against the mirror. Okay. It's kind of tough because I'm using these markers, which are larger points. So I just want to make sure we're doing it right. So you can see maybe it's not totally accurate because I didn't start at the very tip, but we're going to do our best. Anyways, so the ray travels from the point through the focal point and then hits the mirror, and the reflection is going to bounce straight back, again, parallel to the principal axis. Okay. And again, our reflected rays, we're going to draw these lines behind the mirror. So the reflected rays travels this way and bounces off that way. And then our third point, our third ray, is going to travel through the center of curvature and the point. So it's going to travel through the center, and it's going to behave as if, because it's the center of curvature, it's going to bounce off the mirror here and bounce straight back. Okay. So, a couple things to notice here is when the object is between F and C, the reflections never intersect. So the reflected rays are going to reflect in front of the mirror. Now, if you look at our diagram here, you can see that the rays intersect at 2 points. That's not okay though, because I'm going to blame the fat markers and the fact that I drew this green ray improperly. Okay, so I'm just going to take a quick little break, redraw this, and I'll be right back showing you a better version. Okay, I had to go to Mars for a minute, but I'm back now and I got t-shirts for everybody. But seriously, I had to redraw this thing a little bit. And when you make your own diagrams, sometimes, if the measurements aren't perfect, the ray diagrams don't work out exactly the way you want them to. So, point of the story though, I've redrawn it. I used a smaller object and I had to move the center of curvature because I didn't measure perfectly from the focal point to the mirror. And so the center of curvature is also known as 2f, which means twice the focal distance. And so anyways, I had the dot too far back, which means the lines weren't all meeting up where they were supposed to. So it's my fault. Now, to get back to the story though, if you'll notice, the first ray in red hits the mirror and travels back through the focal point. The next ray travels through the focal point to the mirror and passes back along the principal, or parallel along the principal axis. The third ray travels through the center of curvature, hits the mirror, and travels straight backwards again. Okay, so all three of these lines now line up right here. They all intersect, I should say, sorry. They intersect there, and so our image is going to be right here. And so, because of that, we can write down that the location of our image is in front of the mirror. The orientation is inverted, which means upside down, right? The arrow's pointing up over here. The object is pointing up. The image is pointing down. The size of our object is larger, right? The image is larger than the object, and the type is real. Okay, we've got a real image here because it's the reflected rays that are lining up. Okay, if you'll remember from my first attempt, which failed, but we learn from our failures, we fail forward. All of our reflected rays, they diverge, right? They're going out, they're not intersecting on the hard or behind the mirror. They're intersecting in front of the mirror. So we've got a real image. If the rays intersect behind the mirror, we've got a virtual image, but because for a ray diagram for an object between the focal point and the center of curvature in a concave mirror, the reflected rays intersect in front of the mirror, we have a real image. All right? So I apologize if there's any confusion. Feel free to email me. See your teacher in class in person. That's the best way to get the fastest answer. But I hope it helped. We'll be back later for an object beyond the center of curvature.